going to do a quick review about the exponent laws, and we're going to move to learning about new exponent laws that we haven't learned in grade 11. Okay, so let's just quickly review what the base is and what the exponent is and stuff like that. So the power is an expression made up of two parts. So we have the base, the exponent, or the power. Could be power or exponent, they're the same. So if I'm looking at 5 to the power of 4, what's my base, what's my exponent? Base is 5, exponent is, how about negative 5 to the power of 4? What's my base? Negative 5, and my exponent is 4. How about x to the power of 3? X is the base, and the exponent is 3. How about 7 to the power of negative 3? So the base is 7, and the exponent is negative 3. How about negative 5 to the power of 3? What's my base here? So you're saying 5, you're saying negative 5, you're saying negative 5. Which one is the right answer?
Negative 5 brackets.
It's not in brackets, right? So in here, because this was in brackets, right, this is my base. The base is negative 5, and all of it is to the power of 4, right? But in this case, I do not have the bracket. So only the 5, only this 5, is the 1 to the power of 3. That negative is not to the power of 3.
So it's just 5.
So my base is just 5. And then my exponent is 3. What's the base for the last one?
3x.
3x. And then the exponent is 3. So it's important to know when to put the brackets and when not to put the brackets. Okay? Especially when you have even exponents. Right? Because this and this will not give you the same answer. Okay? What's the difference? What's going to be the answer for the first one and the second one?
It's going to be negative.
One's going to be negative and then the other one's going to be negative. So the first one's going to be
That's going to be negative.
negative, and what's 5 to the power of 4? What's 5 to the power of 4? 625, that's what I'm thinking about. Is that right? 625? What's 25 times 25? Should be.
That's 125. 625, sorry. 25 times.
Now, for the second one, it's going to be negative 5 to the power of 4. That's going to be positive 625, right? Because this is basically negative 5 times negative 5 times negative 5 times negative 5, right? So negative, 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 negative gives me positive, right? So that's going to be 625. In this case, I only have one negative, and I have 5 times 5 times 5 times 5. And that's why it's ending up being negative. Do you guys understand the difference between the two? So basically what they're saying here is multiplying the same thing by itself so many times, right? So when I say 5 to the power of 4, what I mean is it's 5 times 5 times 5 times 5. So I don't write it this way, right? Because otherwise it takes forever. We have a calculator that does this for us, but we need to understand what that means. If I have negative 5 to the power of 4, that's like saying negative 5 times negative 5 times negative 5 times negative 5. not shown if there is no exponent, what does that mean? What's your exponent then? 1. Alright, so if you have x by itself, it's x to the power of 1, or if you have 2 by itself, it's 2 to the power of 1. Okay. So the rule says that if I'm multiplying two powers or more than two powers, if I'm multiplying the powers with the same base, what do I do with the exponent? I add the exponent. Now, there's few words here that we have to be careful with, right? When I multiply powers with the same base, you have to have the same base in order for you to be able to do this. If your bases are not the same, then you can't add your exponents. So I have 5 to the power of 5 times 5 to the power of 4. I have the same base here, right? So both bases are 5. So all what I have to do is I have to add the exponent to keep the base the same. So that's going to be 5 to the power of 9. How about the next one? I have 2x times 4x squared. I have to make them the same base. How can I make them the same base? Which one is the smallest, the smaller base? So 2x is the smaller base, right? So I have to make this one, if I can, the same base as the 2x. Can I write 4x squared as 2x to the power of something?
Yes.
What would it be? 2x to the power of 4. 2. Right? So this stays the same. Now this one, I can write it as 2 squared x squared, right? So the 4, I can write it as 2 squared. Yeah? So that's the same thing. Because these have the same power right here, because they have the same power, I can actually write it like this. Yeah? That just because these two are multiplied together and they have the same power, I can do that. Okay? So that's going to be 2x to the power of 2x to the power of what? What do I do with my exponent? Add them. I have an exponent of 1 here. It's an invisible one. Right? So that's going to be 2x to the power of 3. Which is, if I want to expand this, what would this be? 2x times 2x times 2x. Is that what you said? Yeah. Which is what? What's 2x times 2x times 2x?
6x cubed.
8 what?
Sorry.
8 what?
8x cubed.
8x. Right? Now, let's say if I did not want to do the same base. Okay? And I wanted to take this and multiply. What's an easier way to do that?
Should just get the final answer?
Yeah.
Just multiply the two bases together and add the exponents.
So what do I multiply by what?
2x times 4x would give you 8x, and then you just add the exponents, so that would just be 8x cubed.
Okay. So in this case, I multiply the coefficient together, so 2 times 4. Right? We always multiply the number by the number. And then because these are the same base, right, you just add your exponents, right, which means it's x cubed. So in this case, I know what the answer is going to be, right? So I can check my work. But at the same time, this is basically what I'm expecting. I'm not, unless I say write them to the same base, right? I'm okay with this, the 8x cubed right away. Okay? But sometimes you have to. That's the only way you can do things, is by writing them to the same base. Okay? Are you guys okay with both methods? Okay, if I'm dividing two terms with the same base, what do I do with the exponent?
Subtract.
I subtract. Again, it has to be the same base. If it's not the same base, I can't do that. So what do I do with the negative 6 to the power of 10 divided by negative 6 to the power of negative 2?
Well, if you're taking away -2, you're gonna have to exponent of 12 because you're taking away.
You're taking away a negative, right? So I have negative 6. It's also in bracket, right? Because my negative 6 is in bracket, right? And if I do 10, take away negative 2, that's the same thing as adding 2, right? So that's going to be negative 6 to the power of 12. Okay, next one. What do I do? Where do I start my simplification?
3 and 6.
The 3 and the 6, right? I can simplify the 3 and the 6. What's 3 divided by 6? 1 over 2, right? Because if I divide this by 3, that gives me 1. If I divide this by 3, it gives me 2, right? So it's 1 over 2. Good. How about when I do x4 divided by x2? What do I do?
x2.
x2. So subtract the exponent. So 4 minus 2, that's x2. Where do I put it?
X2 on top and then
Okay. How about y5 over y?
y4.
y4, right? On the top as well. So you can write it like this, or you can write it like this. That means the same thing, right? This and this, they're the same thing. Technically, the answer is going to be x2 y4 over 2, right? That's the easiest way to write it, okay? But all of these, this, and this, they mean exactly the same thing. They're written in different ways, but they're exactly the same thing. Are we okay with that, guys? Now, if I have a power to the power, what do I do with my exponent? So if I have something like this where you have
Multiply your powers here.
that's right, you multiply. So if I have 3 to the power of 4 and then to the power of 5, 3 to the power of 20. So because I have 4 times 5, so it's going to be 3 to the power of 20. I have negative x to the power of 3 and then to the power of 7. What is that?
Negative x to the power of 21.
Yep. And then negative x stays in the bracket. So these are all review from grade 11. Okay? divided, I distribute the exponent to each item being multiplied and or divided. So I distribute. So be careful here because you must have multiplication or division. If you have addition or subtraction, you can't do this. Is that clear? People like to do it with addition and subtraction, but it's not possible. So if you have negative 3, x to the power of 4, all to the power of 3, you can distribute that cube to every term inside the bracket. Okay? So then you're going to end up having negative 3 in bracket to the power of 3, and then you have x to the power of 4 to the power of 3. So you see how that power of 3 has been distributed to both terms that are multiplied together inside the bracket.
Yeah.
Okay? So what's negative 3 to the power of 3? Negative 27. Okay? And then how about x to the power of 4 to the power of 3? X to the power of 12. Right? Because you're multiplying your exponent. Remember, power to the power, I multiply. A lot of times students forget to distribute that exponent to the number, right? That's where the mistake happens. Okay, so I have 4y to the power of 5 divided by 6x squared, all squared. How would I distribute that to it? So what would be to the power of 2? 4 to the power of 2. Y to the power of 5 to the power of 2. Now you don't have to write this step. I'm just writing this step so I show you what's happening. Okay, you can skip that step if you know what you're doing. Okay? Then what happened to the denominator? 6 to the power of 2 to the power of 2. Okay? 4 to the power of 2 is? What's 4 to the power of 2? What's 4 times 4?
60.
What's y to the power of 5 squared?
Y10.
Y to the power of 10. What's 6 to the power of 2?
36.
Yeah. And what's x squared to the power of 2? X to the power. Now, technically, you're going to have to look at your final answer and make sure there's nothing can be simplified, right? Before you can say I'm done, right? Can I simplify anything with this? What?
10 and 4. Also
16 and
36.
16 and 36. Can I simplify the 10 and 4?
No.
No, because
They don't have the same base.
they don't have the same base. Okay, so what can I divide both 16 and 36 by?
8. No. 4.
4. Because I can divide both by 4. That's going to be 4y10 over 36 divided by 4. That gives me 9x to the power of 4, right? The 4 and the 9, they won't be simplified anymore. So basically, I divided both of these terms. This one, I divided it by 4, and this one, I divided it by 4, and I ended up with that answer.
Instead of y, x, then we could reduce
Yes.
that to
Yes, if you had an x instead of the y, then yes, you can. But in this case, you can't because they're different bases. Now then we come to the next law, which is the zero exponent law. Any base raised to an exponent of 0 is equal to
1.
1. Anything, any number that is to the power of 0 is going to equal to 1. Any number, any letter, anything. Okay? That reason for that is because look at this. If you have, let's say, x to the power of 6 divided by x to the power of 6, right? What do you want to do with this?
Just cancel it.
Just cancel it, and what would you end up with?
Zero. Oh,
When you divide 10 by 10, what do you get? When you divide 100 by 100, what do you get? When you divide 1,032 divided by 1,032, what do you get?
still the same.
1, right? Anything we divide by itself, it's equal to 1, right? So this is basically equals to 1, right? Now let's use the exponent law. If I have x to the power of 6 divided by x to the power of 6, what do I do with the exponent? Subtract them. What's 6 minus 6?
0.
So that's x to the power of 0, right? So x to the power of 0 is equal to 1. You see that? So anytime you have anything to the power of 0 is going to equal to 1. Because technically, there's two things that are divided by each other and then they simplify. Do you guys understand that part? All right. Now, let's look at this one. So I have 3x squared times y to the power of negative 6 all to the power of 0. What is that equal to? It's just 1. Because that whole thing is to the power of 0, which is equal to 1. So what do you want to do with this one? 3 to the power of 2 to the power of 4 to the power of 0.
We have to brackets.
So what do you want to do?
Inside the bracket, we're gonna solve them outside.
So 2 times 4 plus.
So you want to multiply the exponents together? 2 times 4 is 8. 8 times 0 is? 8 times 0 is? 8 times 0 is? 0. So it's going to be 3 to the power of 0. What's 3 to the power of 0? 1. Then we come to the negative exponent law. So any base raised to a negative exponent is equal to the reciprocal of the base to the same positive exponent. So the word says, to the reciprocal. Do you guys know what a word reciprocal means? The flip, yeah, of the base raised to the same positive exponent. Okay? So basically this is telling you that if you have a negative exponent, you want to flip your base, make your exponent positive. Okay? So let's look at the first one. Actually, let's look at the second one first. The second one is easier. So if I have 1/5 all to the power of negative 2. Okay? So you're going to have to flip your base. So what does it become? 5 over 1. And then instead of power of negative 2, it's going to become power of 2. Which is the same thing as saying 5 to the power of 2, which is 25. Okay? That's going to be your final. Now, how about the first one? What needs to be flipped? What needs to be kept the same? What would I write?
Just put it over 1.
Put what over what? So, but the thing is, you're going to have to look at each term. Is each one of them to the power of a negative?
No.
No. So the 3 and the z, they are not to the power of a negative. So I can't flip these two. Okay? However, these two I can flip. Okay? So there's different ways that you can do this. You can look at this and then leave this as 3. Flip this, it becomes 1 over x. To the power of 4. Flip this, it's 1 over y to the power of 3. And then keep this the same, it's going to be z. This is not clean. This is not this is not how your final answer should look like. This tells me that, yes, you know your rules, but you don't know math. Yes. So, how can I write this in a neater way? is like this, right? So I can multiply all my numerator together, right? So it's going to be 3 times 1, which is 3, times z is 3z, right? And then the denominator together, okay? Another way that you can look at this is if it has a negative exponent, it's going to come to the denominator. So my denominator for now is 1, right? So if I want to write this, I'm going to leave the 3z on the top because they have positive exponent, and then bring these to the bottom, to the denominator, so that's going to be x4, y3. Okay? So whatever is negative comes to the denominator, and then the positive exponent stays up there. Or you can write it like this, and then simplify by multiplying your numerator together, so it's going to be 3z over, and then multiply your denominator together, so it's going to be x4, y3. Okay? So there's 2 different ways that you can think about this. You can write it this way, or you can right away go from here to here by just moving your negative exponent to the denominator and making them equal. Are we okay with that? All right, so let's just summarize these for now. So am times an, so I just have to add my exponent because I have the same base. I keep the base the same and add my exponent. If I'm dividing, I keep the base the same and I subtract the exponent. If I have power to the power, I multiply my exponent. Anything to the power of 0 is 1. If I have a b to the power of m, that m gets distributed to all the terms, so it's going to be am bm. A to the power of a negative exponent, I flip the base, so it becomes 1 over a to the power of m. Now there is a difference. Guys, can I have your attention for a second? So if this is written like this, you should write it as 1 over am. But the minute that you have something that looks like this, you should keep it in bracket, and then keep the bracket to the power. Okay? So if this was, let's say, 3 to the power of negative 3 over 2 to the power of negative 2. So in this case, only the 3 is to the power of negative 2. But the minute I have this, eyes on the board please. The minute I have this, that's a totally different question. Okay? In this case, only the 3 is to the power of negative 2. In this case, both of them are to the power of negative 2. Okay? So the answer for this, let's look at this, because this is very important, and a lot of time the students don't understand the difference between them. So in this case, only the 3 is to the power of negative 2. So what do I do to make it positive 2? Flip what? 2 will not go up in this case, okay? And that's why I gave you the difference here. This, in this case, only the 3 is going to come down. The 2 is going to stay down there, and then the 3 is going to come down to become 3 to the power of 2. Okay? This is very important. Okay? So, only the 3 is to the power of negative 2. So, only the 3 that's going to come down to the denominator. And it's going to become positive 2. Okay? So that's going to be 1 over 2 times 9, which is going to be 1 over 18. Okay? In this case, because it's in brackets, the whole base is going to flip. So this is going to be 2 over 3 to the power of 2, which is 4 over 9. You see the difference in the answer? You guys see the difference? So you have to be careful how you're writing your, if there is a bracket, you're going to keep the bracket. If there's no bracket, you can't just create one. Okay? in this case, if I have a over b to the power of m, the m will be distributed to both a and b, so that's going to be a to the power of m over b to the power of m. And then for the last one, what do I write?
B over A.
In bracket
Yes.
to the power of. Okay, so what I want you to do for this one is I'm going to give you some time to work on this. So you're going to simplify first, then you're going to plug in 1 for A, -2 for B, 3 for C, and then you're going to find your final answer. But first, I want you to simplify.